I bet you didn't know that the Andromeda Galaxy, our closest galactic neighbor, is a colossal island of stars stretching over 220,000 light-years across. Imagine looking up at the night sky and seeing a faint, hazy patch of light. It might seem insignificant at first glance, just a smudge against the dark canvas of the night. Now, imagine that this patch of light is actually made up of billions, even trillions of stars, all clustered together in a massive structure. That's a galaxy. Each tiny point of light is a sun, possibly with its own system of planets. Galaxies are like giant islands of stars scattered throughout the universe. They are the building blocks of the cosmos, each one a bustling metropolis of stellar activity. They come in various shapes and sizes, some spiral-shaped with elegant winding arms, others elliptical, like stretched-out spheres, and some with irregular, undefined forms that defy easy classification. Each galaxy is a vast collection of stars, gas, dust, and planets, all held together by gravity. These components interact in complex ways, creating the dynamic environments we observe. These cosmic islands are spread out over incredible distances, with vast stretches of mostly empty space separating them. The distances are so immense that light from some galaxies takes millions of years to reach us. Yet, even across these cosmic gulfs, galaxies interact and influence each other through gravity, sometimes even colliding in spectacular displays of cosmic fireworks. These interactions can trigger new star formation and reshape entire galaxies. Studying galaxies helps us understand the universe's vastness and our place within it. Through telescopes and other instruments, astronomers can peer into the distant past and uncover the secrets of galaxy formation and evolution. It allows us to explore the life cycles of stars, the formation of planets, and the mysteries of black holes, pushing the boundaries of our knowledge about the cosmos. Each discovery brings us one step closer to understanding the grand tapestry of the universe. Among the billions of galaxies in the observable universe, there's one we call home, the Milky Way. Our solar system, with the Sun at its center and Earth as the third rock from the Sun, resides in this vast, spiral-shaped galaxy. From our vantage point on Earth, deep within the Milky Way's disk, we see its billions of stars as a band of light stretching across the night sky. This band appears milky white to the naked eye, hence the name Milky Way. The Milky Way is a barred spiral galaxy, meaning it has a central bar-shaped structure from which spiral arms extend outward. Our solar system is located within one of these spiral arms, about 2/3 of the way out from the galactic center. The Milky Way is constantly rotating, with stars and other objects orbiting around the galactic center. It's a dynamic and ever-evolving structure shaped by the interplay of gravity, star formation, and the remnants of past stellar explosions. Now, if we journey far beyond the outskirts of our Milky Way, we encounter another magnificent spiral galaxy, Andromeda. Also known as Messier 31 or M31, Andromeda is the closest major galaxy to our own. Like the Milky Way, Andromeda is a barred spiral galaxy, but it's significantly larger than our galaxy, estimated to contain as many as 1 trillion stars. From our perspective on Earth, Andromeda appears as a faint, fuzzy patch in the constellation of Andromeda. However, if we could observe it from a point outside our galaxy, the view would be breathtaking. Andromeda's spiral arms, filled with bright blue star-forming regions and dark lanes of dust, would sprawl across the cosmic canvas, showcasing the beauty and grandeur of this galactic neighbor. Andromeda is not just a beautiful sight, it's a valuable cosmic laboratory. Studying Andromeda provides astronomers with insights into galaxy formation, evolution, and the dynamics of large-scale structures in the universe. Andromeda's significance extends beyond its visual appeal and scientific value. It plays a crucial role in the future evolution of our own galaxy. Astronomers have discovered that Andromeda is moving towards the Milky Way at a speed of approximately 68 miles per second, or 110 kilometers per second. This galactic collision course means that in about 4.5 billion years, Andromeda and the Milky Way are destined to collide. This collision won't be a catastrophic event like those depicted in science fiction movies. Instead, it will be a slow, drawn-out process lasting billions of years. As the two galaxies merge, their stars, gas, and dust will interact gravitationally, altering their shapes and triggering waves of star formation. Ultimately, the Milky Way and Andromeda will coalesce into a single, giant, elliptical galaxy. Studying Andromeda helps us understand the dynamics of such galactic mergers and predict the future of our own cosmic neighborhood. Given its significance, you might wonder, how far away is this galactic neighbor? The answer is mind-boggling. Andromeda is approximately 2.5 million light-years away from Earth. To put that distance into perspective, consider that a light-year is the distance light travels in 1 year, which is about 5.88 trillion miles, or 9.46 trillion kilometers. So, Andromeda's distance translates to a staggering 14.7 quintillion miles, or 23.6 quintillion kilometers. This vast distance means that the light we see from Andromeda today started its journey towards Earth about 2.5 million years ago, back when our early human ancestors were taking their first steps on the African savanna. Measuring such immense distances requires specialized techniques that go beyond traditional methods used on Earth. Astronomers have developed ingenious tools and techniques to calculate the distances to stars and galaxies, unraveling the scale of the cosmos. One of the primary methods used to determine the distance to Andromeda is based on a type of star called a Cepheid variable. These stars have unique properties that make them incredibly useful for astronomers. Cepheid variables are pulsating stars that brighten and dim in a predictable pattern. This regularity allows scientists to study them in great detail. The period of their pulsation is directly related to their intrinsic brightness. This means that by measuring how long it takes for a Cepheid to go from bright to dim and back again, we can determine its true luminosity. By observing the period of a Cepheid variable in Andromeda, astronomers can determine its intrinsic brightness. This is a crucial step in the process of measuring cosmic distances. Comparing this intrinsic brightness to the star's apparent brightness, which is how bright it appears from Earth, allows them to calculate its distance. This comparison is fundamental in the field of astronomy. This method, known as the standard candle technique, has been instrumental in measuring the distances to nearby galaxies like Andromeda. It has provided a foundation for our understanding of the universe. It relies on the principle that the fainter an object appears, the farther away it is. This principle is known as the inverse square law and is a cornerstone of astronomical measurements. In addition to Cepheid variables, astronomers use other methods to refine the distance to Andromeda, such as observations of supernovae or exploding stars, which can also serve as standard candles, and the motions of stars within the galaxy. By studying these motions, astronomers can gain additional insights into the structure and distance of Andromeda. These multiple lines of evidence converge to provide a reliable estimate of Andromeda's distance. This convergence of data from various methods ensures the accuracy and reliability of our measurements. As technology advances, astronomers continue to develop more sophisticated instruments and observational techniques, pushing the boundaries of what we can see and understand about the universe. These advancements are allowing us to study Andromeda in greater detail than ever before, revealing intricate structures and phenomena that were previously hidden from our view. Future observations promise to unlock even more secrets about this fascinating galaxy, potentially answering questions about its formation, evolution, and the role it plays in the larger cosmic environment. The James Webb Space Telescope, launched in 2021, is providing unprecedented views of the universe in infrared light, offering a new perspective on Andromeda and other distant galaxies. JWST's high resolution and sensitivity allow it to peer through the dust and gas that obscure our view of Andromeda, revealing details about its star formation, stellar populations, and the supermassive black hole at its center. This new data is crucial for understanding the life cycle of galaxies. Ground-based telescopes are also undergoing significant upgrades and improvements, enhancing their ability to observe Andromeda with greater clarity and precision. These advancements, coupled with new data analysis techniques, will enable astronomers to create more accurate maps of Andromeda's structure, study its dynamics in greater detail, and gain a deeper understanding of its evolution. This comprehensive approach will help us piece together the history of this neighboring galaxy. The future of Andromeda observations is bright, promising to unveil new mysteries and deepen our understanding of this galactic neighbor and its place in the grand cosmic tapestry. As we continue to explore, we are reminded of the endless possibilities that lie ahead in our quest to understand the universe.